Okay, in this video we'll do the last two problems for section G, and the second one you'll have a chance to practice on first. So, this one has a rectangular plot, is enclosed by 200 meters of fence, and has an area of A. We want to show that, once again, the area equals something. So what you see here is X is already labeled for you, so of course that's X. And we know that the total perimeter is 200 meters. So this side would be 200 meters minus 2x, and we want to cut it in half because there's one side here and one side here. Okay, that's probably the easiest way to look at that. Maybe a different way would be well, you see here we can simplify. That'll simplify to 100 minus x. So that's what our other side of our rectangle is. Area of a rectangle, of course, is base times height. We have a base, we have a height. The base is 100 minus x. The height is x. Let's distribute, so that's 100x minus x squared, and that's what the problem started up here by asking us to show, and we've now done that. Alright, next. The area is maximized if the rectangle is a square. So we're trying to show that the area is maximized if the rectangle is a square. So what we can do, it might sound like a confusing question, but why don't we try and find the maximum area and see if it's a square. Okay, the maximum, again, we have a parabola that's like that, so the maximum is, of course, our vertex. That's why we're in the optimization section. So, let's optimize. We know that the vertex for the x value is negative b over 2a. b in this case is 100, so negative 100 over 2 times negative 1, our a value. Negatives cancel, and 100 divided by 2 is 50. And that is our x value. So now, go back up and see what happened. The 1 is 50, because that's just x. And the other is 100 minus x, which is 100 minus 50, which is also 50. So our dimensions are 50 by 50, which is, of course, a square. And that is our optimization, and that's how we do this problem. Okay, and now we get to the last one for the section. And what we're going to do here is you try this problem first. See if you can get A and B, or at least try A and then, maybe watch for B. But what I want you to do right now is pause this video and try the problem on your own. After you've tried, you can watch the rest of the video to see if you got the same thing, or watch it to, if you got confused along the way, watch it to figure out what to do. But as for now, pause. Try it yourself first. Okay, and now we'll assume you've already tried it at this point, so now let's go through the answer and you can hopefully confirm that what you did is correct. So this time we have 500 meters of fencing, and we're making 4 rectangular pens, so maybe there's like a horse or something in each one. Find the dimensions that maximize the area of each pen if the plan is like this or like this. So maybe they're debating how to organize their horse house or something. Okay, so let's call that x, which means that and that and that and that and that are all x, the long side. So we know that there are 6 x lengths. And then this side, there are 4 of them. And we know that it's going to be 500 meters of fence. We're going to subtract our 6x, and since there are 4 of those, we'll divide by 4. And how can we simplify? That would be 125 minus 3 halves, so 1.5x. And that's what's equal to that side, the short side. Alright, so now we look at what to do. Same kind of thing as usual. We want to maximize area, so we need an equation for area. Area equals our x side, and we'll multiply by 125 minus 1.5x. And we're also going to multiply, oops, not by 6. Let's change that to a 4. We're going to multiply by 4 because there's 1, 2, 3, 4 areas. Okay, so let's do some math here. So that's 4x on the outside, so 125 times 4, we are back to our 500x, minus 4x times 1.5x. 4 times 1.5 would be 6, and then x times x is 6x squared. Parabola, maximize, same idea you've done 3 or 4 times now. Negative b, so negative 500 over 2a, a is negative 6, so negative 12. And negatives cancel. Then what is 500 divided by 12? So that's 250 over 6. Keep simplifying, 125 over 3. And that's not going to work, is it? So we type that in our calculator. We get 41.7666, so we round to 7. And that's our answer for part A. What is it asking? Find the dimensions that maximize area. So 41.7 by, and then we plug in that 41.7 to here to get our other dimension. And I definitely don't know that without a calculator either. And when we plug that in, we get 62.5, and then 125 minus 62.5 is also 62.5. So 41.7 by 62.5 is the maximum area for that one. And just real quick, for part B, we're not going to do that in this video. I want to just show you how we would set it up. Oops. Let's take out our pen. So call that x, 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 5 of them. And we can call the little one, the little side, once again, 500 minus 5x, and divide by, how many are there? 1, 2, 3, 4, 5, 6, 7, 8. We divide by 8. So that is one side, that's the other. So we would do the same thing. We're back to basically this problem. So one side, x times this up here, and then times 4 again, because there are 4 rectangles, and then again find the vertex. So you, again, should be able to do that now, since especially we did part A and already set up part B, so make sure you take a look at that before Tuesday. Alright, and that's it for section G.